Welcome back to my video series for Unit 4. In this video, we'll be going over residuals. This will be the last video, so hopefully after this you'll feel very ready for the test. In this video, you're going to learn how to calculate residuals, both by hand and by calculator, how to graph a residual plot by hand, and if you want, I can show you calculator as well, and lots and lots and lots of calculator help, because we all need that. All right, so let's get started. In this example, we are using the same example about the history teacher wanting to know the test scores of students from the least squares regression video. So if you don't know where I got these numbers or how to calculate those numbers, go back, watch the least squares regression video, and then come watch this video, and it'll make a lot more sense. This line also comes from that video too. I showed you how to graph that line. So what this line is the least squares regression line. This is the line that makes predictions. This line is all of the y-hats, all of the predicted y's. So essentially, let's look at hour 5. This is hour 5. If somebody slept 5 hours, they got a 63 on the test. That's this number right here. But according to our equation, this is what we thought they would have got. So I'm just going to plug that in to see what we thought they should have got. So 35.75 plus 6.36 times 5. So according to our equation, we thought that the person should have got a 67.55. So our prediction was too high. This difference right here that we're off by is called a residual. A residual is how much, residual, is how much your observed y differs from your predicted y. So in other words, how far is y from y hat? So in our example, when we figured out, we saw that for 5 hours, we saw somebody get a 63 on the exam, but our equation predicted they should have got a 67.55. Well, if we do 63 minus 67.55, we get negative 4.55. So we were off by negative 4 units. So we were quite a bit off, but still pretty close, I guess. 63 to 67. So I guess if this was a magic trick, maybe people would not be that excited, but I think it was pretty good. So let's refresh our memories. What does a negative residual mean? A negative residual means that you over-predicted. Okay, so look at that number is our prediction, and it's bigger than that number. So same idea, but go backwards now. What if you have a positive residual? Well, that means you under-predicted. Okay, well, what if we did get 63? We got 63 minus 63, like we have a residual of 0. Well, that means you are perfect. Just like I tell you every day in class. Got to throw in a corny joke in there too. Okay, so that's the way you guys should be looking at evaluating your residuals. All right? All right. So let's go over how would you do this on your calculator, because I just showed you how to do one residual by hand. What if you wanted to do lots of them? So what you're going to do is you're going to go to your list, which I've already have stored in my calculator, and then you're going to move your cursor up to the L3. And you're going to write your least squares regression line. So currently, I just wrote a little key of what I'm doing. In list 1, I have X. In list 2, I have Y. In list 3, I'm going to put my least squares regression line, my Y hat. So to do that, I'm going to write that equation. But your calculator needs to know where the X is stored. So under list 3, I'm going to write 35.75 plus 6.36 times X, but X is in list 1. So watch me do that. 35.75 plus 6.36 times list 1. You're going to push enter, and those are all the predicted values. Okay, so just like what we did by hand, remember the one we did by hand for 5 hours was 67.55. There it is right there. Okay, and we just said that a residual is y minus y hat. Well, the calculator doesn't understand that, so you have to be very, tell it exactly where those numbers are located. So the y's are all in list 2. The y hats are all in list 3. So in order to do y minus y hat, I need to do list 2 minus list 3. And those are my residuals. So that means how far off I was. So remember the one we did by hand, negative 4.55? That means that's how far all of my guesses were. All right, so now we want to see if a data set is linear or not. The way we look at that is we need to look for patterns in the residual plot. So to do that, we're going to graph our residuals. So you'll see right here, I wrote down what was in the calculator on the paper so it was easier just to reference. And what I'd like you guys to do is when you graph these, I want you to, I don't know how to do this, but maybe put a pen or pencil on top and just pretend that those two middle aren't there. Because when you graph a residual plot, you're graphing x, comma, residual. So you're graphing essentially list 1 and list 4. So you want to take all the data from list 1 and list 4 and make those ordered pairs and graph those. So I'll do a couple of them. I won't do all of them. So let's see, the first one is 8, negative 3. So 8, negative 3. The next one is 7, 5.7. 7, 5.7. Actually, I can do these pretty fast. 7, negative 6. 8, 1.3. 6, 2.09. 5, negative 4. 7, 9. This is really rough sketch. Sorry, guys. 4, negative 1. 9, negative 3.99. And 7.73. All right. So there is my residual plot. So you have to ask yourself, do you see a pattern? And usually your pattern will look like a parabola. Do you see a parabola? I see a bunch of dots scattered all over the paper, so I don't see a pattern. And then we learned that if you do not see a pattern, then the form of the graph is linear. So this data set is linear. Just for review, don't forget that if you do see a pattern, so for instance, you get a residual plot and it looks like this, something like that, that means the form is not linear. And that's not what we're looking for. This is what we're looking for. Okay, so make sure you know the difference between the two. And if you want, you can stop the video now, or I can show you very quickly how to graph your residual plot on the calculator so you can compare your two answers. Okay, so actually I'll do it over here so that way you can see if we get the same thing. So you're going to push second y equals, and you're going to go to plot 1. And you're going to make sure it's on, pick the scatter plot, and remember we're graphing x and residual. So your x's are in list 1 and your residuals are in list 4, so I got to change that. So that's x and residual. When I'm ready, I push zoom 9, and there's my graph. So it looks pretty close. This looks like this. You got 3 above here, you've got 2 over here, 2 over here, 1. Ooh, I must have messed that one up. But you get the idea. So hopefully that helps. You've got lots of ways to check your work before you turn in your test. I think you guys are going to be doing great on this test. You've been studying really hard and hopefully watching these videos, and I wish you the best. But if you have any last minute questions, come find me and ask away. Have a great day.